because it doesn't use the basic amount. So I guess what we want to do is the probability weighted amount. Crap. Well, okay, first of all, let's handle the easy case. Oh, that's here. Crap. This is going to be Q2Y equals amount. This amount needs to go out there. Let's just set it 0 for now, I guess. I guess we could set this to product amount. And then if product amount is nil, then we're going to set the local delta is going to be product dot max amount max product dot amount min, and then amount is going to be product dot amount min plus delta times product dot probability. Yes, so that should be the expected value for what the recipe will give us. So if there is an amount on the product, then we'll just use that. If there's not an amount on the product because there's a min and a max and a probability, then we will use the expected value here. Now this is going to be potentially problematic, because the rest of our AI now needs to know that when I ask the tree resource, or I mean for trees we know it's going to be okay, but when we ask the resource source, how many am I going to get if I go and mine whatever this item is, the answer may not be correct. And this is really bad because now we need to basically do the check to go and get stuff multiple times. And any other math that we do that's like, oh, I need to go and get this tree, that tree, and this tree, we might do all those 3 trees and then realize we still have to go and do more, which is a less efficient planning route. However, this is exactly how a human would play, I think, if you knew all the numbers. The other way to do this would be to just set the amount that we're expecting to get to be the minimum amount, and then we'll always be safe. That would be the more conservative approach. So maybe we'll come back to this at another point. Okay, we'll just leave that for now. Okay, so this is how much the tree is going to give us. That's good. Now, I think what we want to do is basically provide an interface where the manager can ask the resource source to enqueue a task to gather that resource. So there will be a function on here somewhere that is something like gather, something like that. And it would take a quantity, and it would take a goal machine and a player. So let's just do, I guess, opts. So this is going to be a quantity, the player is going to be player, obviously, and machine is going to be the goal machine. Machine. Okay. So now, in order to do the tree mining, what we're going to do is, I believe it's mine resource. Is the task? Is this the one that moves? No, this goes and finds it. Okay, so we probably need to do the move to point and then mine entity. Oh no, mine entity handles the moving as well. Okay, great. Oh. I wonder if I needed to make those two the same. I probably did, huh? That could be the reason my mining wasn't working the other day. Well, we'll see. Okay, so mine entity task is exactly what I want to do. So in this case, I just want to do something like opt stop machine, push single. Do we want to do it now? Or do I just want to return the task? What do I need here? Self.entity. Okay, so then the other thing is we want to know when this resource is no longer valid. So I think we can do that in the parent function, in the parent class here, and just have a check if it is valid. Source. Is it valid or is valid? Valid. Okay, because once you mine the tree, it's gone. So that's it. Okay, give me 1 second. I just gotta go blow my nose. Okay. So the resource manager. Oh man, this is that's dubby. I'm just thinking about the resource manager having a list of resources or sources, and then having to filter them. I'm wondering if it might be better to just have this sources be a map of the resource name type to a list of resource sources. That might be better. Oh, that's the other thing, right? The name is going to be tree instead of resource. Name is going to be like hairy wood tree, whatever. For trees, it should be resource. Hmm. Goddamn trees. Alright, I think we just need to handle the trees differently. Okay. And then self sources, I think. Yeah, do something like if self sources resource. Oh shit, I'm reusing the name here. This is the entity, I guess. Entities. Entities. This is for each product. Okay, so I don't need to handle this here anymore, the product management. Right, okay, so that defeats my map idea. So I was going to have a map of resource types to these resource source classes. But since the resources are managed by like the recipes that you get when you mine them, or the list of products that you get when you mine them, it may not be just one thing. And so rather than do that work here, I'd rather do that inside the resource source and then have it the provides type function, let you know that this thing provides that resource rather than having to like compute that up here. So we'll just add this resource into the list. Now for the initialize, I know these are all going to be iron, copper, coal, and stone. It'd be really neat to have a good generic class. We're also going to have to handle the case where the resource is like alien orbs, alien artifacts, and then the method of going to mine it will be like instead of a mine entity task, it will have to be a like freedomize area task, distribute freedom task, and then have to go and do some alien killings. Okay, so yeah, we're just adding the list in here. I know for this like I said, it's going to be I'm going to call it a ground resource, I guess, just to make it easy to tell. So let's duplicate it, and we'll call this ground resource. Okay. Okay. So for the ground resources, I'm not super worried about the probabilities or anything like that. I think the amount that that we're going to get from ground resources is not based on this mineable properties. It's actually just going to be 1-to-1 based on the product, based on the name of the thing. So the compute types here. Actually, what do I need to do here? I need to put. Oh, I didn't even do it over the tree. I need to put something into self.types. So for ground resource source, I'm basically just going to set self.types equals an object, an array here, and that's going to be type equals self.entity.name. I guess it does have a product, but the amount is based on the self.entity.amount, right? Which is the like 500 units of iron ore. So that's all I need to do for here. Here we will need to specify the quantity. So because you don't have control for a tree, you just cut the tree down and then you get the wood and that's it. For the